So hello dear students, welcome back. Welcome to the rapid revision series. Let's start with the first topic, epidemiology. We'll try to look at it in a very concise and crisp manner, okay? Addressing all the important questions, all the important high-yield points as well, okay? So who's this person? This person is none other than John M. Last, okay? Why is John M. Last so famous? Because he gave the definition of epidemiology. He has also given the definition of health education. So let us start with what is the definition of epidemiology. So what do you study in epidemiology? It is the study of frequency, distribution, and determinants of a disease or health-related events in a community. That's the first part of the definition. And the second part is an application of this study to control diseases or health problems. Okay, so that's the definition given by John M. Last. Here there are three very, very important components. What are they? Frequency we are studying, distribution and determinants, okay, of a disease or any health related event. And we are not just studying them, we are applying that concept to control the diseases or health problems. So after this epidemiology definition, the question that was asked is, okay, what are the three components that you studied? You are studying the frequency of a disease, all right? Frequency of a disease means numbers. Frequency means numbers. What is happening to the incidence and prevalence of a disease? Then we are also studying the distribution of a disease, okay? We are studying the distribution of a disease, as well as we are studying what? The determinants of a disease. So we are studying three most important things. Now, when I talk about disease frequency, the frequency of a disease is represented by what? Incidence and prevalence of a disease. Okay, incidence and prevalence of a disease. How many cases are there? Whether the cases of a disease are increasing, decreasing, all right? All that is studied under frequency. Then the second one is disease distribution. So here we are trying to study the distribution of a disease. How is the disease distributed in terms of time, place and person, okay? What time of the year is the disease occurring? Is it more seen in winter, summers, which time? Whom is it affecting? Is it more affecting the males, females, children, elderly? All right. People residing in lower socioeconomic class, upper socioeconomic class, okay. And of course, place, urban area, rural areas, countries, villages. So that is what is distribution. And last but not the least, we are also studying determinants. So determinant is given by why and how, which is like, what are the reasons? We are trying to understand the etiologies that could lead to the occurrence of a disease. So in epidemiology, we are studying frequency, distribution, determinants. Now, each of these components is being studied with the help of study designs. Okay. So when we talk about disease frequency, okay, the disease frequency is expressed in terms of incidence and prevalence. So there are certain tools of measurement in epidemiology, okay. How will you measure the disease frequency? Okay, how will disease frequency be measured? Okay, so what are the tools that we can use? So we can use rate, ratio or proportion. All right, rate, ratio or proportion. These are the tools used in epidemiology to express the frequencies. Now, obviously a question comes, I've taught you this before also, what is the difference between a rate, ratio and proportion? Now, first thing, see, whenever I say rate, ratio, proportion, each of this has a numerator and a denominator. So in rate also there is a numerator, there is a denominator. Now, what is happening actually in rate? The numerator n is part of d. But what is the multiplier, everybody? The multiplier can be 1000 or it can be 10,000 or it can also be 1 lakh. Okay, the multiplier is 1000, 10,000 or 1 lakh. That is what is the meaning of rate. What is a proportion? Now, a proportion also has a N and D. That means a numerator and a denominator. And what is this? N is part of D. Okay, N is part of D. But what is the multiplier in proportion? The multiplier in proportion is always 100. Okay, what is the multiplier? 100. So whenever you see the multiplier as 100, okay, multiplier is 100, it becomes what is known as a proportion. But when the numerator is part of denominator and the multiplier is 1000, 10,000 or 1 lakh, it is what? A rate. Okay? Next, ratio. What is ratio? N and D. It also has a N and D. But the important thing is that this N and this D, alright, N is not a part of D. So in ratio, what is happening? N is not a part of D, means numerator is not a part of denominator. Like we have discussed before, sex ratio. What is sex ratio? It is nothing but number of females per 1000 number of males. So is N a part of D? No. Alright. So rate, ratio, proportion. Those are what? Tools of measurement in epidemiology. How can you express the frequencies? Rate, ratio, proportion. Alright. Rate, numerator is part of denominator, multiply 1000, 10,000, 1 lakh. In proportion, numerator is part of denominator but multiply 100. And in ratio, numerator is not a part of denominator. The most commonly asked question from this topic is difference between incidence and prevalence. So what is incidence, everybody? If I say calculate incidence, what should I say? We say incidence rate. Okay, so what is incidence? Is it rate, ratio, proportion? So when you have to do the definition of incidence, please remember it is the number of new cases, alright, of any disease occurring in a community. Okay, number of new cases of a disease in a community in a year, alright, divided by the total population at risk, alright, total population at risk in a year in that particular community also. So basically, incidence is the number of new cases of a disease in a community in a year. But the important thing is the multiplier is 1000. So what is incidence? Incidence is actually incidence rate. We can very well say that incidence is a rate because numerator has become a part of denominator and what is my multiplier? 1000. But what is the definition of prevalence, everybody? What is the definition of prevalence? It is nothing but total number of cases of a disease. Okay, total number of cases of a disease. When I say total number, it means what? New plus old. Okay, total number of cases, total number of existing cases, the new cases as well as existing cases divided by the total population of the community. But what is the multiplier in prevalence? 100. So since the multiplier is 100, everybody, I say calculate prevalence rate. But is it actually a rate? No. Prevalence is actually a proportion. Okay, very commonly they ask you this. The difference between incidence and prevalence. So incidence is new cases, prevalence is new plus old cases. One more golden point just for your revision. Incidence was calculated from which study design? So it was calculated from, if you remember, incidence is calculated from cohort study. And which study design is helping us calculate prevalence? This is calculated from cross-sectional study. Okay, these are all high yield golden points which can be asked in your exams. Okay? So that's the first part. Now, since we are talking about epidemiology, so we are trying to find out about distribution and determinants. So we need to classify a study design. Okay, how these study designs are classified. Also guys, there's one more thing, that we now know that smoking is a cause of lung cancer, right? Or smoking is associated. Was it always known that smoking is associated with lung cancer? No, it was always not known. So at the very beginning, there is always a assumption which is made, okay? And the assumption which is made, guys, what do you call that? That is a hypothesis, okay? So at the beginning, we always make a hypothesis. So hypothesis is also a PYQ. Its definition has been asked. It is what? It is an assumption yet to be verified. Okay, so at the beginning, we always set a assumption, okay, that this could lead to this, or this could be the reason for this. So that is a hypothesis. Now, by means of the study designs, the classification that we will do, we will always try to formulate a hypothesis. Okay, when nothing is known about a disease, we try to formulate a hypothesis. When it's a new disease, like when COVID came, we didn't know it was COVID. We were calling it as pneumonia of unknown origin. We never knew it was COVID. So we formulated a hypothesis, okay, that there is one particular kind of pneumonia which is affecting male population working in bird market in winter months. Okay, so that is formulation of a hypothesis. Then what do? We test a hypothesis. Test a hypothesis means those who suffered from COVID were compared with those who did not suffer from COVID. And lastly, we confirm a hypothesis. Okay, now confirm a hypothesis, like once we knew it was COVID, we started making drugs and vaccines. Alright, so the purpose of study designs is to formulate a hypothesis, test and confirm. And this is being achieved through the various study designs. Let me just fill in the blanks, then we will see. When you have to formulate, we use descriptive study designs, okay? When we have to test a hypothesis, we use what is known as analytical study design. And when we have to confirm a hypothesis, we use what is known as interventional, alright, / experimental study design, okay? Interventional / experimental study design. So now, based on this concept, let us classify our study designs. So whenever you have to classify your study designs, how do we classify? So if you remember from the lectures, we divided into two bigger halves. One is where you are observing. So observational study design. Next is where you are doing an intervention. Okay, interventional / experimental study design. Okay, one is where we are observing and the second one is where we are doing an intervention or experimental study design. Now see, how can you remember this? So, you complete your PG and everything. Now you have to get married. So you have to go and meet someone. Okay? So you're waiting for that person. So as that person walks in, you observe, right? You look at the person's experience, what he, she is wearing, how he, she is looking, right? Then the person comes and sits. Okay, then you start talking, you intervene. So the first thing is observational. You simply observe. Then you do an intervention. In observational, it is further divided into two halves. What is it? Descriptive and analytical. Now, what is this descriptive and analytical? When you met the person, your parents ask you, how was the person? So you describe. Okay, and then the second question that your parents ask is, was that person better than the previous one you've met? So they start comparing. So in analytical, we compare. Okay, there is always a comparison group. In descriptive, there is no comparison group. Okay, there is no comparison group. So what are we doing? We are describing a disease in terms of time, place and person. Similarly, when COVID happened, we did not know it was COVID. We were calling it as pneumonia of unknown origin. So when nothing is known about a disease, when it's a new disease, we tend to describe it first. That it is affecting this population at this time of the year at this particular place. So we use what study design? A descriptive study design. What were the example of descriptive study design? A case report and a case series. Okay, case report is an individual case study, and an aggregation of case reports make what is known as a case series. In analytical, what do we do, guys? The next thing is that we start to find out the reason why and how the disease occurred. Alright, so we start comparing. What can you do? You can compare people who suffer from the disease with people who do not suffer. So example of analytical, always you need a comparison group. Okay, so what are the examples of analytical study design? Very, very important. The examples are cohort study, case control study, cross-sectional study, and ecological study. We will be studying the golden points related to each of these study designs. Okay. So in descriptive, what is the buzzword? We are studying what? Distribution. Whenever you see the buzzword distribution of disease, that means we are referring to a descriptive study design. Whenever you see the buzzword determinants, we are trying to study the determinants of a disease. So whenever you see the buzzword determinants, that means we are trying to do analytical study design. Okay. Now, once we knew that yes, it is COVID, we start making drugs, we start manufacturing vaccines. So that is what is known as interventional or experimental. We intervene, we do an intervention. So here, what is the classification? There is a randomized control trial, RCTs. Okay. These are what? Drug trials. We divide them into two groups. One gets the new drug, one does not get the new drug or gets the placebo. So drug trials. Then there is something known as field trials. What are field trials? Field trials are nothing but vaccine trials. Now, what do you mean by these vaccine trials? So there's a group of healthy population, half we give the vaccine and the other half we do not give the vaccine. And then we follow them up to see how many went on to develop the disease and how many did not. Also, we have community trials. Okay, community trials are actually preventive trials. Okay, in this what happens? We bring in a sort of prevention. To one community, we give prophylactic iron folic acid, to other we do not. Okay, in one community, we increasing the fluoride content of water and the other we are not. So that is what is preventive trials. But remember, in each of these RCT field trials and community trials, we are doing an intervention. We are actually doing something. Okay? So descriptive study design, everybody, helps us formulate a hypothesis. When nothing is known, we do a descriptive study design. When it's a new disease, okay? Then analytical study design is helping us do what? This helps us test a hypothesis. Test means, how will you test? You'll compare those who suffered from the disease versus those who did not. And then interventional or experimental is helping us confirm a hypothesis. This is a very important revision slide. Okay, remember the example of visiting someone. Okay, so observational, asking him or her for coffee. Interventional, going back home, describing the person you met. So descriptive, and then comparing with the person you've met before. Analytical. Because some of you do tend to forget this. Okay, so that's the classification. Next important thing over here is unit of study. So you just have to know a golden point over here, that all study designs have individuals as unit of study, except ecological. Why? Because in ecological, population is the unit of study. Okay, so all study designs have what? All study designs have individuals as unit of study, except ecological, where population is the unit of study. We'll be reading about this when we take up the individual study designs as well. Okay. So the first study that we will revise is a cohort study, all about the golden points, all about its basic design, some advantage, disadvantage, measure of strength of association, all of that we'll be studying for cohort. So whenever you are asked about any study design, the first question that you need to answer is which type of study it is. So cohort is which type of study? Observational analytical. Okay, it's an observational analytical study. Okay. Next, if somebody asks you what is the meaning of a cohort, so please remember, cohort simply means a group of individuals, all right, who share a common characteristic. Okay, example, all children born in a particular hospital in Delhi today. Okay, so that is a cohort. Similarly, you can have marriage cohort, all those who are getting married together. So any group of individuals who are sharing a common characteristics. Okay, so that is what is the meaning of a cohort. Now, what is the basic design of a cohort study? So important is whenever you will be studying about any study design, okay, you have to know about its basic design. Basic design mein what are the things that you will look? This is a common point for all the study designs. Okay, always remember when is the study starting? Okay, when is the study starting? First point you will notice, what are you comparing? Okay, you will see whether we have a comparison group or not. And the third thing that you're going to see is the direction of study. Are you going forward? Okay. Are you at the same point? Are you standing at the same point? Or are you going backward? These are the three things that we have to note whenever we have to select a study design. Okay, when is the study starting? What is the comparison group? And what is the direction? Are we going forward? Are we standing at the same point? Or are we going backward? So keeping this idea in mind, let us talk about the basic design of a cohort study. Okay, so this is the basic design of a cohort study. Now look over here. The study begins here. Let's say now it is 2023. So the study begins here. That means it's starting in the present time with a study population that does not have a disease. Okay, so we have a cohort. Let's say a group of medical college students who are admitted in 2023, first year medical college students. Okay, now what are we doing? We are dividing them into factor present and factor absent. Here we mean this is the exposed group and this is the non-exposed. Factor present means exposed, against means RF, risk factor present, no risk factor. So let's say we were studying alcohol. Okay, so we have asked them about their alcohol consumption. So factor present alcohol, factor absent no alcohol. So we asked about that, and then look at the arrow, it is going forward. Okay, so first thing, when is the study starting? What are you comparing over here? What is being compared? So what is being compared? We are comparing exposed with non-exposed, right? That's what you're comparing. Then look at the direction, you're going forward and you're looking at the outcome. Disease occurred, no disease in the exposed group. Disease occurred, no disease in the non-exposed group. So this is the basic design. What is this study called as? Of course, a cohort study. You're moving forward in time, but it is also known as a prospective cohort study. There are other names also which come in your exams. So what are the synonyms for a cohort study? Like you saw, you were moving forward with time. So it is known as prospective cohort study. Second thing, you're moving forward. So forward looking study. Third thing, you're moving from what? You're moving from, if you look at this study, from risk factor to outcome, right? So you can say risk factor to disease. You can also say exposure to outcome. And very, very important, they also say, will you say cause to effect or effect to cause? So you are also moving from cause to effect. This is a PYQ. At the same time, guys, what are you calculating here? Since you've divided them into exposed to some risk factor, not exposed, you're following them up for a disease, let's say CVD. So whoever you follow up, and if that person goes on to develop a disease, that will be a new case, obviously. So this is also known as incidence study. And since you were following up, it is also known as follow-up study. Plus, you're moving with time. So, it is concurrent study. Concurrent study matlab, what does it mean? You are moving with time. You're not going against time. Okay, you are moving forward with time. So, these are the various synonyms for a cohort study design which can come in your exam. Exposure outcome, a cause to effect has come. Incidence study is a PYQ. Follow-up study is a PYQ as well. Okay. Now, what were the advantages of a cohort study? Very commonly asked question. What are the advantages of a cohort study? So, now, as you can see, the very important thing is that you've divided them into two groups. Okay. Drinkers, non-drinkers, smokers, non-smokers, and then you are following them up to see how many new cases of a disease develop. So can you say that alcohol led to CVD? Can you say smoking led to lung cancer? Very well. You can say very clearly because you are following them up. Okay. So what is this advantage? The first one, it establishes temporality. Okay, what does it establish? A very important Hills criteria which we will be revising. I'm just putting a golden point here. It's the most important Hills criteria, everybody. What do you mean by temporality? That cause precedes effect. Okay, before lung cancer, the person has smoked. Before CVD happened, the person was drinking. Okay, so drinking led to CVD. Smoking led to lung cancer. So that is cause precedes effect. That is what is known as temporality, and it can very well be established by cohort study. It's the most important Hills criteria of causality. Okay. Second, what is it helping you calculate? A very important thing. It calculates incidence of a disease, which is very, very important. Third, it is also helping you study. Now, you divided them into alcoholics, non-alcoholics, and then you followed them up for the outcome. So, you can study over here CVD, you can study about lung cancer, you can study about any other disease, any other cancer. So, what is this helping you do? It also helps you study about multiple outcomes. You can study multiple outcomes. Okay. So these are the three very important advantages: establishes temporality, calculates incidence, and multiple outcomes. But what is the disadvantage of a prospective cohort? What were the disadvantage of a prospective cohort? See, you have such a long follow-up period. I don't know when the diseases happen. Maybe the disease never happens, right? So we need to follow them for months, for years, for disease to happen. So number one, the disadvantage, it is time taking. Okay. Number two, what is the second disadvantage? Now to follow up somebody, you need funding, you need money, you need something. Okay. So it is at the same time costly. Third, You started with 500 people. See, cohort study always requires a large sample size. Okay, it requires a large sample size. I can't do it with less number of people. I need more number of people. And in between, suppose I started with 500 college students. In between, I saw 200 went missing. Will it affect the outcome of my study? Of course, it will affect. Okay, so that is known as a type of bias. Okay, which is known as, you will see over here, a bias known as attrition bias. Okay, we'll be revising bias also. That means loss to follow up. Okay, it means loss to follow up. You started with 500 students and some of them disappeared. Loss to follow up. It is going to affect the outcome of my study. And fifth, there is also a very important bias seen over here, Hawthorne bias. What is Hawthorne bias? Now, if the participant comes to know that he is being observed, okay, if a smoker comes to know that he is being observed, he might quit smoking. Alright, so that will again affect the outcome of my study. Hawthorne bias is that the subjects modify their behavior on being observed. Alright, so these are the disadvantages. So advantage was also fair enough, temporality, incidence, multiple outcomes, but disadvantage are also there. Should we stop doing a prospective cohort? Or should we stop doing a cohort? No. We came up with a solution to that, in which another type of cohort study came forward, which is known as retrospective cohort study. Okay, synonyms has been discussed. Okay, before we go to the types of cohort study, I just want you to also notice the steps of cohort study. You select the study subjects, you obtain data on exposure. So this was my cohort. We obtain data on exposure, that means exposed, non-exposed. So my comparison group here is non-exposed. The important buzzword is follow-up. If you see the word follow-up in any question, guys, you will know it is a cohort study. This is a buzzword. Okay, if you see the word follow-up mentioned, it means we are referring to cohort. And then we'll do the analysis. Analysis is measure of strength of association in the form of relative risk, attributable risk, and population attributable, which will be discussed. Okay, so that is steps. Now, like I said, that cohort study, a prospective, has disadvantages. So should we stop doing a cohort study? No. We came up with a solution, which was known as retrospective cohort study. So in this, we'll quickly revise about the types of cohort study. One you have already seen, which is known as a prospective cohort study. Okay, and by prospective cohort, you also know it is also known as non-concurrent cohort study. Concurrent means, those who would forget or want an understanding, it simply means we are moving forward with time. Okay, moving what? Moving forward with time. Alright. The second one is what? A retrospective cohort study, which we will be studying right now. Okay. Retrospective cohort study. So retrospective cohort is also known as a non-concurrent study. Non-concurrent means we are not moving parallelly with time, opposite time. Okay, it simply means we are moving opposite time. And then there is something known as mixed cohort study, which is both retrospective plus prospective. So let us talk about each of these study designs. So look at this image. Can you see this image? First thing, how will you know that it is a cohort study? Okay, you will always see that whenever you talk about a cohort study, we are always comparing exposed with non-exposed. Okay, in a cohort, we will always compare exposed to non-exposed. Whether it is a prospective or a retrospective cohort, guys, be very careful. Your comparison group is always exposed and non-exposed. So look at this. Here what is happening, there is a cohort of 117000 nurses. Look at the sample size. They don't have any cancer or CVT. Okay. Then the start of the study. So it is starting at the present time. And we have divided them into, what is the comparison group? Obesity and lean. Alright, so obesity is high risk factor, lean is no risk factor. So obese means this is the exposed group and lean means this is non-exposed. Now, how can you identify which type of study it is? Look at the arrow, it's going forward. And you are comparing incidence. So incidence means it is cohort. And since the direction is going forward, no doubt, this is with study design, a prospective cohort study. Yes, this is a prospective cohort study. Why? You are comparing exposed and non-exposed and you're moving forward. But again, this is time taking and funding expensive and attrition bias, Hawthorne bias. So we found a solution to this. What was that? Look at this study now. Look at this study now. What happens over here? If you look at this, now what happens? You are starting your study here. Okay. And then you are first going backwards. You're taking employees of the tire manufacturers and you've divided them into tire makers and clerical staff. Okay, and then you again come forward to compare incidence. Now, is it a cohort? It's definitely a cohort. Why? Because you are comparing exposed and non-exposed only and you are finding out the incidence. Okay, so this is known as a retrospective cohort. In a retrospective cohort also, what are we doing? We compare exposed with non-exposed. But what did we do? We saved time and money by starting at the present time. So let me just draw another figure for you and show you. Okay. So you start at present time. Let's say in 2023. So your study has started now, but this is the first step. How do you plan to do the study? You go back. Go back means the second step is you use historical data. Okay, now what is the data? I have found a third step. Let's say I have found a college register of a group of medical students. Okay, of a group of medical students who were admitted in a medical college in 2010. So I found that college register. So it's not like from 2023 I've switched to 2010. No, I've just made use of a college register of 2010 and based on that college register, what is my step 4? Based on historical data, okay, based on historical data, what did I do? I have divided the cohort into exposed. Maybe in this there was mention about smokers, those who were smoking at the time of college admission, and here this is non-exposed. This non-exposed means they were non-smokers. So the smoking history was already taken in that register. Then what we have done, we have come forward. So what is the fifth step? We have come forward. Alright, now can you see forward looking? Yes. And now what do? The last step, we determine the outcome. Okay, the outcome is determined at the time the study begins. So outcome determined when? Outcome is determined at the time the study begins. So we are looking at the outcome in 2023 only. And how? By comparing exposed and non-exposed only. So since we compared exposed and non-exposed, it is still a cohort. And because we did not go forward, we first went backward and again came to the present time to determine the outcome. It becomes a retrospective cohort. So outcome, no outcome. Let's say it was CVD, no CVD. Similarly here, we studied CVD, no CVD. Did you understand? Look at it. You start at the present time. Alright, your study you're starting in 2023. How? By using a college register, using a historical data. A college register of 2010. Okay, based on that, you divided your participants into smokers, non-smokers, the history which was taking that time. So you are still comparing exposed, non-exposed, and then you come to the present time to determine the outcome. How many suffered from a disease, how many did not. So now, why is this a cohort? Remember, it is a cohort. Okay, why is it a cohort? Because whether it is prospective or it is retrospective, guys, what are we doing? We are always comparing what? We always compare exposed with non-exposed. Okay, this is the golden thing. Okay, the only advantage of retrospective cohort is that it saved money, because you did not have to follow them for years. You still can say that smoking has led to CVD because you've compared exposed and non-exposed, but you were able to save time and money. Saved money and it saved time. All right. Plus, no loss to follow up. That problem is not there. No loss to follow up. No Hawthorne bias. But it can still calculate incidence. Okay. Because we have first seen exposure status and it can establish temporality. So overall, if somebody asks you which is better, a retrospective cohort or a prospective cohort, the moral of the story is always remember a retrospective cohort, guys, is much better than a prospective cohort. This is a golden point. Okay. It's saving time, money, but at the same time, it is calculating incidence. At the same time, it is helping us establish temporality. So a retrospective cohort is definitely better than a prospective cohort. Am I clear, everybody? This is very important. Please don't forget this. Okay, this can definitely come in your exams. Once again, let us have a look at these images. Here you started at present time, divided into exposed, non-exposed, went forward to compare the outcome. Prospective. But here I start at the present time, but I'm not moving forward. I've gone backward. I have divided them into tire makers, which is exposed, and clerical staff, which is non-exposed, and then I have determined how many of them died in both the groups at the start of the study. So this is a retrospective cohort or a non-concurrent cohort. So we are still, and why is it cohort? Because you're still comparing exposed and non-exposed. Now you might ask me the difference from a case control. So we'll do that as we revise case control. In case control also, guys, I'll just mention it. You start at the present time, but at the present time, the outcome has already occurred. Okay. So you are comparing diseased and non-disease. But in a cohort, whether it's prospective or retrospective, you will always compare exposed and non-exposed. There's another type of study which is known as a mixed cohort study, guys. What is mixed cohort study? Now, as you can see over here, you start the study, let's say in 2023. Okay. Now, first we go back. All right. We've used a college register or something and we've divided the cohort into exposed, non-exposed. Then we come forward, all right, and see it's bi-directional. We come forward and we look at the incidence of skin rash at the start of the study. So it's definitely a cohort. This part is a retrospective cohort. Okay, you look at the incidence of skin rash at the time the study begins. Then those who suffer from skin rash and those who do not suffer, they again become two groups, and then we follow them to in the future. Okay, followed into future, to see how many go on to develop cancer and how many don't. So this is prospective. At the present time when the study started, we divided it into two groups again. People who developed skin rash and people who had no skin rash. And then we went forward, we followed them into future to look at how many went on to develop cancer and how many don't. So this is a mixed cohort. Mixed cohort, there was another term, please remember, ambispective cohort. Okay, and whenever you have mixed cohort, it means both retrospective and prospective part combined. Okay. Now, I'll give you certain examples. Just tell me what it is. Look at this. In a study begun in 1965, a group of 3,000 adults in Baltimore were asked about alcohol consumption. The occurrence of cancer was studied between 1981 and 1995. So, which type of study it is? It's very obvious that you are starting your study with 3,000 adults. In which year? In 1965. You've asked about alcohol consumption. So, in half, some of them are alcoholics and some of them over here are non-alcoholics. Then what are you doing? You're studying the occurrence of cancer in 1981. So, cancer in this group, no cancer. Again in 1981 among non-alcoholics, how many suffered from cancer? No cancer. And then you're again asking the occurrence of cancer in 1995. Okay, so you're looking at cancer, no cancer, cancer and no cancer. So it's very obvious that you're moving forward, isn't it? And what are you comparing? Exposed, non-exposed and moving forward. So this is a prospective cohort. Okay. Now here I would like to tell you something about, is it a horizontal design or a vertical design? Of course, it's a horizontal design. You're not standing at one place. Okay, it's a horizontal study design. Maybe this can come as a buzzword, horizontal study. Horizontal means you're moving forward. Here, can you notice one thing, that we are looking at outcome at fixed time intervals, 1985, 1995. Okay, so we looked at outcome at fixed time intervals. So please remember, when outcomes, okay, when outcomes are looked at fixed time interval, like I've decided that every 6 months I will see the outcome, or every 1 year I'll see the outcome. So same group, I'm following them over the years and I'm seeing the outcome, let's say at every 6 months. So when the outcomes are looked at fixed time intervals, that I will be seeing every 6 months or every 1 year, alright, a special term is given to this, that is known as longitudinal study. So please don't get confused. Always remember, longitudinal study is a type of a cohort study only. Okay? So if I write over here, remember, longitudinal study is what? Is a type of a cohort study only. Okay, what is it? It's a type of a cohort study only when we are looking at the outcomes at fixed time interval. Okay? So if anybody asks you longitudinal and this is prospective cohort is the same, it's similar. It's the same thing. But in longitudinal, we have decided that the beginning only, that every 6 months or 1 year, we'll be looking at the outcomes. Okay? So that is a longitudinal study, similar to a prospective cohort. Okay? Is a type of prospective cohort only. Look at the other option. 500 women aged 40 to 54 who present for routine checkups are asked about their meat consumption. 20% of the women turn out to be vegetarian. During the ensuing 5 years, 5 vegetarians and 43 non-vegetarians develop colorectal. So which type of study? Always try to determine one more thing. Whenever you get a question like this, what is the exposure and what is the outcome? So what is the exposure over here? The exposure over here is vegetarian versus veggie versus non-veggie, right? That is the exposure factor over here. Veggie versus non-veggie. And what is my outcome that I'm studying? We are studying colorectal cancer. Okay, and I'm starting with 500 women. So we start with 500 women who presented with a checkup, asked about their meat consumption. So this is veggies. Alright, this one over here, guys, is non-veggies. And then we are ensuing means just to play off English words. Ensuing means next. Next 5 years means follow-up of 5 years. Yes, next 5 years. So we are moving forward. In the next 5 years, we see among the veggies and non-veggies, how many go on to develop colorectal cancer? No colorectal cancer. Similarly, over here in non-veggie groups, we have colorectal cancer. No colorectal cancer. So it's pretty obvious. What is this? This is a prospective cohort. So the first thing we did, we looked at what is the exposure outcome, when are we starting the study, and we are moving forward. So prospective cohort. Look at this. After retrospective cohort study, if another study is done in forward direction for another 15 to 20 years, that means in this study, we have both retrospective plus prospective. We have both retrospective plus prospective component. So this is what? This is nothing but a mixed cohort study, or we can also call it as an ambispective cohort, right? First we did retrospective, then we moved forward in the prospective direction. So retrospective cohort. All right. So please remember, always whenever you get an image, you see when is the study starting. Are you moving forward? Are you moving backward? And what are you comparing? So far, we were comparing exposed, non-exposed. So it is cohort. Now, in a cohort, we are starting at present time and moving forward, prospective. We are starting at present time but moving backward and again dividing them into exposed, non-exposed, comparing and determining the outcome at the time the study begins, a retrospective cohort. When we see case control, I'll tell you once again the difference between a retrospective cohort and a case control. Now, what are the measures of strength of association in a cohort study? So, cohort study or a case control, they are all used to express strength of association. Like, suppose we are studying smoking and lung cancer. So we know smoking is the exposure here and lung cancer is the outcome. So we have to know how strong is the association. I am not saying that smoking is a cause. I am saying smoking is associated with lung cancer. So how strong is association? Now, what do you mean by association? There's a difference between association and causality. Okay, association means when two factors, all right, or when two factors occur more often together, when two factors occur more often together than expected by chance, okay, than expected by chance. So when two factors occur more often together than expected by chance, that means chance has always a 5% role. More than 5% chance the two factors are coming together. Like every time a study is done on lung cancer, smoking is associated, okay, as a risk factor. So how strong is that association? So in a cohort study, that is expressed by three things, okay. One is relative risk. We'll be talking about this. The other one, guys, is attributable risk, okay. And the third one is PAR, population attributable risk. So let us study about it. For this, always remember we need to make a 2x2 table, okay, 2 into 2 table. Now, you'll not memorize this, you'll understand the concept, okay. So example, we are studying, we have to study association between what? We have to study association between smoking and CVD. Let's say. So we know smoking is the exposure and CVD is the outcome. So always the outcome will come on the column side. CVD, yes, no. And here we have smoking. Yes, no. Okay, so this is your outcome always on the column side and this is your risk factor or exposure always on the row side. So this is A, B, C, D. Always remember it is going row wise, A, B, C, D. Never write A, B, C, D. That's wrong. A, B, C, D. Now what is relative risk? The other term for relative risk, guys, is risk ratio. Nowadays, instead of writing relative risk, they also write risk ratio. Okay, so relative risk is also known as risk ratio. So what is the formula for this? What do you calculate in a cohort? Incidence, right? So this is what? Incidence among exposed divided by incidence among non-exposed. A simple formula. It's a ratio, so numerator cannot be a part of denominator. So incidence among exposed divided by non-exposed. Now here you have total. Okay, A plus B, C plus D. Now can you tell me what is incidence among exposed? So you can see over here how many are exposed, how many are smoking. A plus B. Right? Don't memorize, just understand. How many are smoking? Yes, A plus B. Out of them, how many have CVD? Yes, A. Okay? And what is incidence among non-exposed? Now again see how many are non-exposed. Okay, let's use this color. Non-exposed is C plus D. So that is C plus D. Out of them, how many are suffering from CVD? C. So this is the relative risk. Relative risk is always a ratio. Numerator is not a part of denominator. Okay. So incidence exposed among non-exposed. Can you see this? Appreciate this. So all those who are smoking together, A plus B, out of them how many went on to develop CVD? A. How many are non-smokers? C plus D. Out of them how many went on to develop CVD? C. Alright. Now what is the interpretation of relative risk? A favorite examiner question. Okay. Interpretation of relative risk. Now always remember, in any study you can obtain relative risk more than one, equal to 1 or less than 1. More than 1 means positive association. Equal to 1 means no association. And less than 1 means negative association. Now what does this mean? Positive association. Suppose I get a relative risk of 4.5 or 4. It simply means that those who are smoking are 4 times at risk of lung cancer. So positive means it is a risk factor. No association means whether you smoke or not, it has nothing to do with the outcome. Negative means inverse association. Okay, inverse association. Or you can also say it is a protective factor. Like there came a question, we were studying association of, let us say, herbal tea. Okay, we were studying the association of herbal tea and diabetes. Okay, now in this the question was risk ratio. Okay, RR or risk ratio was 0.8. So what will you interpret? Is herbal tea a risk factor for diabetes? Does herbal tea have no association with occurrence of diabetes? Or is herbal tea a protective factor? So you can very well see that this risk ratio is less than 1. So we can easily conclude that herbal tea is a protective factor. Okay, it's a protective factor for what? It's a protective factor for diabetes. Got it? That's how we interpret relative risk. So that's important. The next one is attributable risk. 2 by 2 table will be the same. But what is the formula? This is difference in exposed and non-exposed. That is what the question came. Okay, so it is incidence among exposed minus incidence among non-exposed divided by incidence among exposed. Can you see this is a difference and the multiplier is always 100. It's expressed as a percentage. Okay, incidence among exposed minus non-exposed divided by exposed. So you already know what is incidence among exposed, A upon A plus B. Non-exposed, you already know it is C upon C plus D. So you just have to put those formula. Now suppose we were studying smoking and lung cancer. So example, attributable risk that we obtained between smoking and lung cancer. Alright, we obtained an attributable risk of 75%. So what does this mean? That 75% of lung cancer is attributed to smoking. Okay, this is of use to epidemiologists, okay, who are studying about diseases. Last but not the least is population attributable risk. In population attributable risk, I'll just draw a column once again. Okay, CVD, a 2 by 2 table. Yes, no. Now suppose we were studying smoking. Yes, no. So this is A, B, C, D. Alright. Now remember what is the formula for population attributable risk, okay, which will come in your exams. So in population attributable risk, guys, the formula is incidence among two. It's also a difference, but it's incidence among total population minus incidence among non-exposed, okay, divided by incidence among total population multiplied by 100. So it's, what are we looking at? We are looking at the incidence among the total population. So you already know What is the incidence among non-exposed? But can you look at the table and appreciate what is incidence among total population? If you see, what will you say? It is, what is the total population over here? Everybody A plus B plus C plus D. Yes, A plus B plus C plus D. And what is the incidence among total population? That means, what is the incidence of CVD among total population? CVD, yes, it's present in A plus C. Right? So that is the incidence among total population. Total population is A plus B plus C plus D, and out of them CVD is happening in A plus C. So this becomes your numerator. Incidence among total population. So PAR would be incidence among total population, which is A plus C by A plus B plus C plus D minus incidence among non-exposed. So not smoking, total C plus D, out of them CVD in C. So minus C upon C plus D divided by A plus C by A plus B plus C plus D. Okay, multiplied by 100. So relative risk was incidence exposed, non-exposed. Attributable risk is incidence exposed minus non-exposed divided by incidence exposed. Population attributable risk is incidence among total population minus non-exposed divided by total population. More important than the calculation of PAR is its interpretation. So what is the interpretation? Suppose we were studying smoking and lung cancer. Okay, and PAR, okay, example, PAR calculated as 90%. Your examiner asks you, what does it mean? You've calculated PAR as 90% between smoking and lung cancer. What do you mean by this? It simply means that if smoking is eliminated, okay, as a risk factor, okay, if smoking is eliminated as a risk factor, there will be 90% reduction in, look at the second part, okay, annual incidence of lung cancer cases in the population. Okay, what did we say? That if smoking is eliminated as a risk factor, there will be 90% reduction in annual incidence of lung cancer cases in the population. So, the question that arises, if 90% of reduction will be there in the rate at which cancer cases were happening 1 year in the entire population, should we launch a smoking cessation activity? Of course we should. So population attributable risk is of importance to whom? This is of importance to policy makers. Okay, whom is it importance to? The policy makers. We can see that a substantial number of lung cancer cases will reduce every year. Okay? So why not launch a preventive modality for smoking? So this is of importance to policy makers, health administrators. Okay? So these are the measures of strength of association. We'll be practicing MCQ. Any of this can come in your exam. Okay? So you must remember cohort, type of study, the basic design, the synonyms, the advantage, disadvantage. Why did we have to bring a retrospective cohort study? Okay, what is mixed cohort, and the various measures of strength of association. Now let us come to another type of study, case control. We'll do all the golden points of this as well. So when you're asked, case control is a type of its study design. Again, it's a type of observational analytical study. Okay? Now, like I said, in a cohort, we always look at when you're starting the study, what you're comparing, and the direction. Okay, so in a case control, guys, always remember we start the study at present time. But it's a case control. So we have a comparison group, control, and case. So we always compare cases. Cases means diseased. Okay, and controls. Controls means what? The non-diseased. So we are comparing this and we are moving backwards. So we are moving what? Retrospective in direction. Alright, look at the image. Now you start at the present time, your population, but look at your comparison group, cases and controls. Now you can ask me, ma'am, how is it different from retrospective cohort? In a retrospective cohort, also you start at present time. I completely agree. But was I comparing cases and control? No. The outcome might have occurred, but we determined it at the time the study begins. So I was not starting with diseased and non-diseased. I had gone back, I had taken a population, used historical data and divided them into, let's say, exposed and non-exposed, and then I had come forward in time to look at the outcome, right? I had determined the outcome at the time the study begins, okay? So here in a retrospective cohort, what did we do? We determined the outcome at the time the study begins, right? We didn't start with the outcome. We determined it at the time the study begins. Therefore, this was retrospective cohort. And the important thing is, what were you comparing? You were still comparing exposed and non-exposed, okay? This was my comparison group. But look at case control now. What? Look at case control. In case control, we start with diseased and we start with diseased and non-diseased. What is it that I'm comparing? I'm comparing diseased and non-diseased, okay? And I'm just going backwards. I'm asking how many of you smoked, how many did not. So we went backwards, retrospective, okay? But we compared what? Cases and controls. In retrospective cohort, what do you compare? Exposed to non-exposed. Always remember that. Okay? So based on this, what are the synonyms for a case control study design, guys? Now, as you can see, it is also known as a retrospective study. If they just mention retrospective study, we are referring to a retrospective case control. For a cohort, they will say retrospective cohort. Okay. Then we are moving backwards. So backward looking study. Then you are moving from outcome to exposure. Disease to risk factor. Now, is it cause to effect or effect to cause? Effect has already happened. So, it is effect to cause, right? Then, it is also the opposite of a cohort. So, TROHOC. Opposite of cohort. Clear? Alright, so if you see the buzzwords like backward looking study, effect to cause, we are referring to it as case control. Okay, now what was the advantage of case control? That it can save time. Obviously, you are already starting with people who have disease versus those who don't have disease. Then it is saving money. Relatively inexpensive, right? The disease has already occurred. What can I do? Save money. And the third thing also that you can study, like in a cohort, we were comparing exposed, non-exposed and moving forward to look at outcomes. Here we are starting with cancer, no cancer, and I can go backward and ask about your smoking history, your alcohol history, your dietary factors, so many things. So we study multiple exposures. Also remember, whenever you have rare diseases, okay, it's always feasible or better to do a case control, because rather than waiting for years for that disease to occur or determining the disease at the time the study begins, let us start with a case control. Let us take people who suffer from the disease versus who do not suffer. So it is very good for studying rare diseases. Here I'd like to mention one point. For rare exposures, example, occupational exposure. Which study design can you select? So remember, for rare exposure like occupational, you can study cohort because the exposure is rare. So it's again better to begin with that exposed and non-exposed. And when the disease is rare, it's always better to start with it. So, case control. That is advantage. But then there was a disadvantage that it cannot calculate incidence. Okay. It cannot calculate incidence. It cannot establish temporality. Okay. Cannot calculate incidence, cannot establish temporality of the disease because disease has already occurred. But still it is telling us something about the strength of association. Okay? Now, look at the steps of a case control. You select the cases and control. You match them. Now, this word we will be studying matching. Like in cohort study, the buzzword was follow-up. Whenever you see the word matching, it should give you an idea that we are referring to a case control study. Matching means that the cases and controls are similar to almost, or similar means they are matched for almost all the factors, okay, which can affect the outcome of the study. And when I say these factors, I'm referring to a term known as confounders. So matching is eliminating, okay, this we'll study in confounder also, we'll just revise it. Matching eliminates, please remember, all the known confounders from a study, okay, all the known confounders from a study. What do I mean by that? Now, I know that if I'm studying, let's say, alcohol and CVD, there could be confounders like age, religion, gender, socioeconomic status, area of residence. So, I know these factors can affect the outcome of my study. So, I'm going to match my cases and control. Like, if I'm selecting my case from lower socioeconomic class, I'll select my controls also from lower socioeconomic class. If I'm selecting my cases as elderly, my controls also should be elderly. So, I'm matching them for the factors which can affect the outcome of my study, which are known as confounders. But matching only eliminates, guys, the known confounders. So, if you see a buzzword like matching, you should know it is referring to a case control. Then you will measure how much. You go back and assess the exposure status and do an analysis. Analysis in a case control is expressed in terms of odds ratio, which we will just see. Matching is a method to eliminate known confounders. We will be seeing confounders also in detail. Here I want to tell you one more golden point, guys, that for one case, max how many controls can be taken? Max number of controls taken is 4. Okay, for one case, we can maximum take 4. Otherwise, 1:1 is also sufficient. Okay. If the cost of collecting cases and control is the same, then 1:1 is also sufficient. But if somebody asks you max how many controls you can take for one case, so you can take 4 controls. Okay? Now look at this question. A researcher wants to study relation of depression with history of social media use. Look at the word history. Okay. One group had social media users with depression and the other group had social media users without depression. What is it? So like I said, what is the approach you are going to take? What is the approach? So the first thing you have to identify is what is the exposure and what is the outcome. So what is the exposure over here? Of course, it is social media usage. And what is the outcome over here? It is depression. Okay. You're studying history. History is reflecting on the term that we are going back. Now, what are you comparing? You can see one group had social media users with depression and another group had users without depression. So, you are comparing those depressed with those who are non-depressed, right? You are comparing those who are depressed with those who are non-depressed, isn't it? You are comparing that only, those who are depressed with non-depressed, plus you're going back, and plus depression. Is it a very common thing? See, ideally we could say that I'm depressed, you're depressed, like that. But are we clinically diagnosed? No, hardly any one of us is clinically diagnosed. So again, when you talk about depression, it's a rare disease. It's a rare outcome. Alright, so it's always better that you start your study, divide it into people who are depressed, okay, and over here people who are non-depressed. And then you're studying a history. So history means you're going back and you're asking, did you use social media? Social media use? No use. Similarly here, social media use? no use. So what did you do? You went back. Okay, history you took. So you went back and you had two groups, one depressed, non-depressed. So this obviously, guys, is a case control study design. So the first thing that you figured out was the exposure, then you figured out the outcome, then you went back and compared the exposure status. Now, look at this, the most feasible design to assess relationship between breast cancer and risk factor OCP. Now again, most feasible I'm saying, which can easily be done. So rather than starting and dividing people into OCP, non-OCP users and then following them up, for breast cancer, no breast cancer, or starting at present time, going back, using history, dividing them into OCP users, no OCP, and determining breast cancer at the time the study begins. Best is I have a population in which I have breast cancer cases, okay, breast cancer cases, and here I have no breast cancer, alright, and then I can just go back and I can ask them about OCP use, no OCP use. Similarly, here I can ask OCP use, no OCP use. Are you understanding? So here again, breast cancer is rare. Any cancer is rare. Although we know breast cancer is now the most common cancer globally in India, but that doesn't mean every second woman is having cancer, right? When you're asked the most feasible design, best is you should start with that particular disease, okay? Now look at this. An investigator suspects that acetaminophen used during first trimester of pregnancy can cause NTDs. She estimates the risk of NTD in general population as 1:1000. So the risk is every 1000 kid, one can have NTD. Which of the following study is to investigate? Now, can you make pregnant women take acetaminophen and follow them up for NTDs in the baby? Unethical, right? So again, the best thing is you have a population, and this is a rare thing. 1 in 100 children is presenting with the neural tube defect. So you have this population, you divide it into children with NTD and no NTD. And then you simply, what you do, you simply go back and ask their mothers, take a history from the mothers. Did you use acetaminophen, right? Acetaminophen use, not used. Similarly, in no NTD also, you asked acetaminophen use and not used. So this again is a case control study design. Okay? That's how you will do. And how do you measure the strength of association? It is given by something known as odds ratio. Alright. Or you can also say it as cross product ratio. So what is this? Suppose here I have disease. Cases and controls. Here risk factor present, not present. Again the same thing, ABCD. Outcome, exposure. So odds ratio is a cross product ratio. What does this mean? This. That means AD upon BC. And what are the values that you can get? Odds ratio more than 1 is, again, just like relative risk, positive association. Equal to 1 means no association, guys. And less than 1 means, again, it is a protective factor. Got it? So that's how we express case control study design, measure of strength of association. Like if you get a question over here, how can you estimate? Always remember this is A, B, C, D. Can you see this? It's never A, B, C, D. That's wrong. A, B, C, D. So what is odds ratio? Cross product ratio. So it is AD upon BC. 30 into 30 by 20 into 20. So this is 9 by 4. So 2.5. Alright, so again, whatever we are studying, CAD, alright, and smoking. So smoking is definitely a risk factor. That means those who are cases of CAD had 2.5 times more exposed to smoking than no CAD, or they had 2.5 times more odds of smoking than no CAD cases. Okay. Alright. There's also something known as nested case control. Now, nested case control is actually, just have to know that what type of design it is. It's a nested case control. So, the case control is a nest in something bigger. Okay. So, nested case control is actually a smaller case control, a nest. Nest of what? A nest of a case control. So it's a smaller case control in a bigger cohort. That means this tree over here is a cohort and this nest over here is a case control. Now, what does this mean? It's a smaller case control in a bigger cohort. They can also write it's a smaller cohort in a bigger case control. No, it's a smaller case control in a bigger cohort. What do I mean by this? So, suppose today in one of the hospitals in Delhi, 100 children are born. Okay, so these 100 children who are born in one of the hospitals in Delhi today is my cohort. Now, what do I do is, I have taken these mothers' antenatal history, okay, antenatal history. We have preserved their blood samples, okay, we have preserved, let's say, the urine samples. We have also preserved, let's say, their stem cells. Now, what I do, these 100 children, we follow them up. We start follow-up. Okay, we start the follow-up. Let's say we follow these children for 50 years. Now, after 50 years, they are all adults. Okay. Now, out of these 100 children, we observe that 10 have developed a disease. So, those 10 become cases and 90 controls. Okay. These 90 do not develop disease. So, these 90 are what my controls and these 10 have become cases. After like 50 years of follow-up. So, what has been the direction? It has come forward. Right? So, what is it? Actually, it is prospective in nature. We have actually come forward. Now, what I do to save money, alright, I'm not going to test all of these people. I start a smaller case control. That means, for these 10 cases, I initiate a smaller case control in this bigger cohort. Meaning, I go back, okay, and I take out the samples of only these 10 cases and analyze them to see what could be the likely cause of disease in them 10 years later. Had it something to do during the time they were born? Was it some mother's history? Was it some thyroid level when they were babies? What was it? Okay. So what am I going to do? I'm going to go backward. First we came forward. Look at this orange arrow. We've come forward. Then we go backwards. Okay. And analyze what? We go backwards and analyze the samples of only the cases. Okay, we analyze the samples of only these 10 cases, not everybody. So, in a way, we saved money. Instead of, doing the investigation for all these 100 people, we have only done for them in whom the disease developed. So, again, a golden point is that it is good for what? It must be something rare which has led to the disease in them 50 years later also. So, a nested case control, everyone, okay, is serving two very important purpose. A nested case control is actually good for rare investigations, okay? Alright, and at the same time, it is establishing temporality because it is actually prospective in nature. That's how it is better than a normal case control. In nested case control, it can establish temporality because you've actually come forward. What you've done is that after some years, those who became the disease, we only analyzed their samples. Okay, but we have definitely moved forward. So, how does the question look like? That nested case control, is it prospective in nature or retrospective? It is definitely prospective in nature. It is good for what? Rare investigations. Okay? So, here you can see like this was my population. Initial data we have taken. We followed them over the years to see how many develop disease, how many do not develop. Okay, now suppose if we had started with 500 people, 10 developed the disease, 490 do not develop. So now see, this is bidirectional. We've gone back and we analyze the sample of only the 10 cases who developed the disease. So it is definitely prospective in nature. Okay, and the better thing is it can establish temporality as well and good for rare investigation. And it's this, you can identify this image. How can you say it is nested case control? You can also identify this image by a smaller rectangle over here. This is nested case control in a bigger cohort. Okay. Okay. Moving forward, let us look at another study design now. Can you figure out the difference between this image and the previous ones? Of course, the first thing that you note over here is there is no arrow. So that means when there is no arrow, you are standing at one point of time, or you are standing at same point of time. Okay, you are standing at the same point of time. That means this is like clicking a picture. This is a cross-sectional study design. In a cross-sectional study design, we are neither going forward, okay, neither forward nor backwards. Okay, we're neither moving forward nor we are backward. We're standing at the same point of time. So what are we doing standing at the same point of time? So for cross-sectional study, let's do the golden points. First of all, it is also a type of observational analytical study. Second, it is we determine exposure and outcome at same point of time. Okay, we are not moving forward, we are not moving backwards. Okay, we are determining exposure and outcome at the same point of time. So it's like taking a picture, it's like taking a snapshot of a population. So when you determine exposure and outcome, you can establish or you can calculate very, very important prevalence of a disease. So it calculates prevalence in a study. Okay? So it is also known as a prevalence study. And it is done using primary data. Okay, it is done using primary data. That means the researcher himself collects data. Primary data means researcher himself collects data. I am not going to rely on already collected data. I am going to collect the data myself. And last point, the biggest disadvantage of cross-sectional is, now you know that we are doing it at the same point of time. So we are not moving forward, we are not moving backward. Like I ask you, how many of you drink, how many of you suffer from CVD? You say, I drink, I suffer from CVD. Can I say that drinking has led to CVD in you? No, because I have not followed you up. So the biggest disadvantage is it cannot establish what? It cannot establish what is known as temporality. Okay, so that is the biggest disadvantage. Anything can come from it. It is calculating the prevalence. It is determining exposure and outcome at same point of time using primary data, calculates prevalence but cannot establish temporality. There was no arrow, no forward, no backwards. Okay? So, look over here. A residents of 3 villages with 3 different types of water supply were asked to participate in a study to identify cholera carriers. Because several cholera deaths have occurred in recent past, virtually everyone present at the time submitted to the examination. So, everyone at the time. Plus, the proportion of residents in each village who were carriers were computed and compared. Now, can you see we have 3 groups? Right? For a cohort, we always compare the same group. So, a cohort is out. Whether it's concurrent, non-concurrent, it's out. Why? Because we have 3 different groups, right? In a cohort, we always have the same group. Now, is it cross-sectional case control? Of course, again, case control, we have a population, one population which is divided into cases and controls. So, over here, it is, we have 3 village, A, B, C. One time, one team is going here, one team is going here, team 1, Team 2, Team 3, identifying cholera carriers and comparing it. So, it's done at the same point of time. Okay, and we are collecting fresh data. I'm not relying on some already collected data. So, this is cross-sectional. Okay? Now, look at this. If this image comes to you, this is the image of an ecological study design. This image is actually what we will be revising in biostats. This is the image actually of a scatter diagram. And a scatter diagram was used to represent the correlation. Okay. So, ecological study design is also known as a correlational study. Now in this study, let's first try to interpret it. Okay, if I draw a line like this, I can very well say, and what am I studying? Denmark, UK, Canada, USA. So they are all countries, right? What are they? They are all countries. So one thing is very clear, that my unit of study over here is country, right? And I can very well say that those countries which have higher per capita daily meat consumption are reporting higher colon cancer incidence, right? This is the meaning of this. It's a positive correlation. Okay? So, ecological study design, what are we studying? Country. And we are trying to find an association. So, what are the points that you will remember about ecological study design? Always remember, it's known as a correlational study. It's also known as a geographical study. It's also known as a population study. It's also known as a aggregate study. Alright, number 2. It is just like a cross-sectional study. It is done at same point of time. Alright, but using which data? Using secondary data, not primary data, secondary data. That means, secondary data means already collected data. Okay, we are relying on what? Already collected data. So, it's using what? Secondary data. Alright, mostly it is of use in nutritional surveys. Okay, it's very well of use in nutritional surveys. But the biggest problem with this is the ecological fallacy. Okay, that is the ecological fallacy, which is the disadvantage. Okay, and what is my unit of study? Population. Unit of study is population. Now, what do you mean by ecological fallacy? So, sometimes they can give you that as a question. Ecological fallacy simply means that we generalize the result of population on individuals which they might not have as individuals. Okay, we generalize the result of population on individuals which they might not have as individuals. What do I mean by this? See, here it was said that countries which have high daily meat consumption have higher colon cancer. But what is the problem with that? That those people who are actually suffering from colon cancer might not eating meat. Okay. So, what do I mean? That those people actually suffering from colon cancer may not be eating meat, right? So, this is ecological fallacy. To individuals which they might not have. Population findings to an individual, okay? That is the biggest disadvantage. Otherwise, ecological study is also done at same point of time using secondary data, okay? Already collected data like nutritional surveys and all. Look at this. The research group designed a study to investigate the epidemic of syphilis. The investigators examined per capita income and rate of syphilis in Delhi. Now, you can see Hyderabad, Noida, Mumbai. So, what are we doing? Populations. We are studying cities. Data on citywide syphilis rate was provided by health agency. So, as a researcher, I am not collecting data. I am relying on secondary data. Okay. This secondary data means this is an already collected data. Alright. I am relying on it. The investigators ultimately found that the number of new cases of syphilis was higher in lower income neighborhoods. So, you can see that you are studying cities. That means you are studying populations and you are already using an already collected data, a secondary data. So, this is a ecological study design. Alright. Okay. So, you might ask then why are we doing ecological study designs? Because sometimes it's important to study about populations. Okay. That is why we do it. So, out of what you've so far studied, guys, some golden point I will just quickly tell you. Okay. If you have to study incidence, what type of study? cohort. If you have to study prevalence, what type of study? Cross-sectional, okay? If you have to study multiple exposures, what type of study? Case control, alright? If you have to study multiple outcomes, what type of study? Cohort. If you have to study rare diseases, what type of study? Case control. If you have to study rare exposures, okay, what type of study? Cohort. If you have to study rare investigations, okay, rare investigations, what type of study? Nested case control. Okay, if your unit of study is a population, okay, which type of study? Ecological study. If you see the word correlation, which type of study? Again, ecological study. Some golden points related, okay? Alright, now quickly let's have a look at the types of errors that we encounter in epidemiological studies. Okay, so what are the types of errors in epidemiological studies? Please remember there is one thing known as confounders which can come in your exam, and the other one is bias. Okay, now what is confounders and bias? So let us look at this. See, here we were studying alcohol use and lung cancer. Confounder is written as smoking. So what is confounder? Please remember, confounder is a variable. It could be 1, 2, 3, 4, as many confounders. They are both known and unknown, which gives a faulty association between exposure and outcome. Okay, confounder is what? So let me tell you, confounder is a variable, alright, which has to fulfill certain criteria. Confounder is a variable which is, number one, common to both exposure and outcome. Number two, it is also independent risk factor for outcomes. Okay, number three, it is distributed unequally between the two groups. Okay, exposure and outcome unequally between the two groups. All right, there are both known and unknown confounders in a study. Okay, so look at this. It is common to both exposure and outcome, means those who drink also smoke. Smoking can independently also lead to lung cancer, right? Okay, and smoking is also associated with alcohol use, right? So it is fulfilling the criteria of being called a confounder. Now, confounders do what? They affect the final outcome. Okay, so what do confounders do? Confounding variables, what do? There can be known and unknown confounders. They affect the final outcome. So obviously you need to revise all the techniques to remove confounders. Okay, so what are the techniques if anybody asks you to eliminate confounders? Please remember the techniques to eliminate confounders. Number one, okay, it is matching. It's only done in a case control study design. Okay, case control study. And when you talk about matching, it only eliminates what? It only eliminates the known confounders, everybody, only the known confounders. Okay, it will match the cases and control in every possible variable. Then there is something known as randomization, which we are just going to study. Randomization eliminates both what? Randomization eliminates both known and unknown confounders. Okay, both known and unknown confounders. Okay, then we also have a technique of stratified randomization. Within randomization also we are doing a stratification. So stratified randomization is the best technique. All right, it's the best technique. Then we also have things like restriction. Okay, we have things like restriction. Restriction is done for cohort. If smoking is a confounder, then we'll restrict our study to non-smokers. Okay, that's what it is. Then we also use multivariate regression models. Okay, we can use multivariate regression models. Now, multivariate regression models are best when we have what? When we have multiple confounders. Okay, they are best when we have multiple confounders. So, these can come in your exams. What is a confounder and what is the technique to eliminate it? Next, error is bias. So, always remember, what is bias? It is a systematic error. It doesn't happen by chance. We do it. Okay, it's happening. It's actually occurring. It has nothing to do with chance. Okay, this error is actually occurring. So, it is a systematic error which occurs during design of a study. Okay, when I'm designing a study, during design, conduct of a study, or analysis of a study. Which results in what? Which results in faulty association between exposure and outcome. Okay, it gives a wrong association. Now remember, it is not by chance. Okay, it is not by chance. It is actually happening. It's a serious error. Okay, it's a serious error. And who can commit this error? So it can be committed by a subject. So you can have a subject bias. You can also have a investigator bias. Okay, and we can also have a analyzer bias. Okay, analyzer bias. Nowadays, the person who's doing the investigation is only the analyzer. So, analyzer bias is the least reported. Okay. Alright. And in subject bias, what is the most important bias which you have to revise? So, you all know there is a recall bias, which is seen in a case control study design, and a Hawthorne bias. Okay, Hawthorne bias. This is seen in a cohort. When you have to talk about investigator bias, so again in investigator bias, which type of bias do we have, guys? In investigator bias, you can have very, very important selection bias. Okay, so selection bias is seen in which study design? Again in a case control. I am going to select only those people which I think will give me the result that I want. I know a drug works at 102 degree Fahrenheit. So, I'm going to select only those people who have fever of 102. It will give me the result I want. Okay, selection bias. Then again, it is interviewer bias. Where do you see this? Again, this is seen in a case control study design. I know this is a case. So, I'm going to interview him for longer time. Then you have Bergsonian bias. So this Bergsonian bias is actually a type of selection bias only. Okay, and this occurs due to different hospital admission rate. It occurs due to different what? It occurs due to different hospital admission rate. Alright, one more you can remember over here is misclassification bias. Okay, misclassification bias is also known as information bias. Okay, the exposed have been wrongly classified into non-exposed. Okay, so this is seen in a cohort study. These are some type of bias. Then there was one bias known as Pygmalion bias. Okay, Pygmalion bias is actually a type of investigator bias. Okay, it's a type of investigator bias, meaning increased motivation by teacher. Alright, does what? Increases performance of students. Okay, increases performance of student. Alright, and there is another bias which is known as Golem bias. Golem bias is what? Decreased motivation by teacher does what? Decreased motivation by teacher decreases the performance of students, right? Decreases the performance of student. Alright, so these are bias for whom? These are bias for the investigator who is observing this class. Okay, and last point over here that comes is what is the technique to eliminate bias? What is the technique to eliminate bias? Always remember B for Blinding. Blinding can eliminate bias. Okay. So there are three types of blinding. There is single blinding. Single blinding means the subject is unaware. Okay. Then you have a double blinding. Double blinding means what? Double blinding means both subject and investigator are unaware. Okay. Both subject and investigator are what? Both subject and investigator are unaware. Okay. And what is triple blinding? So when you have to talk about triple blinding, we all know it is subject, investigator and analyzer. Okay. Subject, investigator and analyzer. All are unaware. Okay. Which group, who is going what? Okay. So now the question is that we all know that analyzer is the same as investigator. So obviously best form of blinding, if somebody asks you, alright. So what is the best form of blinding, guys? The best form of blinding is definitely triple blinding. Okay. But which form of blinding is most common? So most common form of blinding, everybody, of course, is the double blinding. Okay? So bias, the buzzword is, it's a systematic error. It's not happening because of chance. It's actually being conducted. And confounders are variables which are common to both exposure and outcome and can affect the exposure and outcome and can affect the result of my study. So you need to know these techniques. Now just the last few things. What is this group? If you see here, it is study group is patient. Alright. And it is being divided into A and B group, treatment and control group. And then we are following them up and comparing the result. So what is this, everybody? This is actually a randomized controlled trial. Okay, this is phase 3 of a clinical trial. It's which type of study? It's an interventional study design. Alright, we are actually doing an intervention. It is always prospective in nature. Okay, it is always prospective in nature. We will always move forward and compare the outcome. And my unit of study is definitely an individual. In that, it is a patient. So the most important thing is that what is the advantage of randomized controlled trial? Or they ask you, what is the meaning of random in RCT, in randomized control trial? See, random generally means something haphazard, but here random means something disciplined. So random in randomization means, okay, random in randomization means very important, okay, that every participant, alright, every participant gets an equal and known chance. This is a PYQ, okay? Every participant gets an equal and known chance of being allocated, alright, of being allocated into either the treatment or control group. Okay, so it ensures what? It ensures comparability. So it eliminates what? Very important. It eliminates what is known as selection bias. Okay. Every participant gets an equal and known chance of being allocated into either the treatment or control group. So it ensures comparability. So it eliminates what? Selection bias. And what is the second point over here? It can distributes confounders. How? Distributes confounders equally between two groups, okay, equally between two groups. So it eliminates what? It also eliminates both known and unknown confounders. It eliminates what? Both known and unknown confounders. This is very important, okay. Randomization is eliminating two things: selection bias as well as confounders, both known as well as unknown confounders. If you have to select one as the answer, like which will be your priority? Selection bias, okay, by ensuring comparability. And confounders, both known as well as unknown. Okay, this is very, very important. That's the advantage of randomization. Okay, all right. Now look at this study design. If you see, which you will get, what is this study? So please remember, we started with a group. We divided them into, let's say, A, which got active treatment, B, placebo. Then there is a period here, wash. Okay, that means we took these groups of their respective treatments and we have crossed them over. The group which was getting active treatment is now getting placebo, and the one that was getting placebo is now getting the active treatment, and then we are analyzing. So this is actually a crossover trial. Okay, so in this what happens, how will you identify it? By the washout period. Okay, this is to remove any residual effect. Okay, those who were taking the new treatment, they are taken off that treatment for some time so that its residual effect can be removed, and those who were on placebo are taken off placebo for some time so that its residual effect can be removed. So what is this crossover trial? You will be asked, every participant, all right, every participant acts as his or her own control. Okay, every participant is acting as his or her own control, and every participant gets the new treatment at least once. New treatment at least once every participant is getting. And one more thing, we can have a smaller sample size also in this. Otherwise, RCT, we need a bigger sample size. But here, because every participant is acting as its own control, so we can start with the smaller sample size also. Plus, it is more ethical. Okay, now there is a term which you must know, which they ask you in exams, intention to treat. Where do you see this intention to treat? It is seen in an RCT only. That means the dropouts are not excluded from the study. What does this mean? That suppose I started with 500 patients, okay, in between some people left my study. So they can also be included in the final analysis, because in an RCT we can do an interim analysis. So there is no attrition bias. Okay, that means there is no attrition bias. Even if there are dropouts, we can include them in the final analysis, okay, because we can do an in-between analysis. So you are simply asked, intention to treat is seen in a RCT, okay? All right, clinical trials phases you must know. So before this, you also have preclinical trials. Okay, preclinical trials are done in animals. Please remember, animal trials are also supposed to be ethical. Okay, plus phase 0 is healthy human volunteers, microdosing, where we use 1/100th of the dose, okay, to see if there is any adverse effect or not. Phase 1 is also healthy human volunteer, extends from months to years. We have participants 10 to 100. We are looking for safety and non-toxicity profile of the drug. Maximum tolerated dose we can calculate in phase 1. Phase 2 again is 1 to 2 years. Okay, we can go for 50 to 500. From phase 2 we start with patients. Effectiveness and efficacy. Okay, maximum drug failures occurs in phase 2. Okay, maximum drug failure guys occurs in phase 2. Phase 3 is actually an RCT. Okay, phase 3 is actually an RCT because here you are comparing 3 to 5 years and it's, look at the sample size, 500 to 3000. You're actually comparing with existing drug. And after phase 3, right? After phase 3, what happens? After phase 3, drug is launched in market. And what is phase 4? Phase 4 is post-marketing surveillance. Alright, once the drug is launched also, we should keep monitoring for any long-term or rare side effects. So ideally, it's phase 4 is also done in patients, large or according to study. It is unending after drug removal. Alright, it's the longest phase. Okay, it's the longest phase. Alright, it should actually continue till the drug is in the market. But we don't have funding for so long. So it is actually continued till 10 to 25 years. Okay, so it is post-marketing surveillance. Alright, now these were the basic study designs that you have to know. Now, this image can definitely come. You all know this is a funnel plot, and where do we draw this? This is drawn for both systematic review and meta-analysis. And why are we drawing this? This is drawn to check for publication bias. Okay, now see, after RCT, which study designs are going to provide us maximum evidence to establish causality? So it is systematic review, and the best is meta-analysis. Because like you've seen in the lecture, in those what you're doing, you are including all the published and unpublished articles together, increasing the sample size, and so it is providing me with the maximum evidence, right? So when we are including the studies, when we are doing a literature review and including our studies, we need to know whether they are good quality or not. So we construct what is known as this funnel plot. So if the dots are scattered like this, it means publication bias not present. If these are individual studies, so if dots are scattered, no bias. But if dots are clustered, bias is present. Okay. And most important image identification, this is what? A forest plot. This is also known as a blobogram. And where do you draw this study, guys? This is only constructed for a meta-analysis. Okay. And this is providing us the overall effect size. Okay, we've included different studies. Now, this diamond tells me the overall effect size. Okay. Now, if you look at this value, is it significant? 1.9 to 2.4, 1 is not included. So, it is significant. Of course, if 1 in interval, alright, if 1 is interval, is included in interval, it is not significant, which we have discussed. You can refer to the lecture on meta-analysis. But here 1 is not in interval, so it is definitely significant, and overall the effect of all these factors that we are studying has a significant effect on the outcome. So remember, meta-analysis is the gold standard of evidence-based medicine. The best study designed to establish causality. So in evidence-based medicine, the concept was given by David Sackett. Okay, he is the father of evidence-based medicine. In evidence-based medicines, we always arrange our studies in a hierarchy. Okay, to establish causality means which study designs provide max evidence for causality. Max evidence for causality. Okay. So when you arrange your study designs, at the lowermost, you have descriptive study designs. So case report. Then we have case series. Opinions and all those are even below that. Okay. Then you have your analytical. Because of ecological fallacy, ecological. Then you have cross-sectional. Okay. After cross-sectional, you have what? Case control. Okay. After case control, we have cohort. In cohort also we have what? Prospective or concurrent cohort. Then we have cohort retrospective. Okay. After this we have what? We have RCT. Then we have systematic review, and top mein meta-analysis. Okay. So please remember, meta-analysis is the gold standard for, it is the gold standard for evidence-based medicine. Okay. It provides us with the maximum evidence to establish causality. And if I asked you longitudinal, where will you put longitudinal? So you know it is similar to a prospective cohort. We have already discussed. So it will come here itself. Okay? This is evidence-based medicine. Alright? How you're going to arrange the study in order to establish causality. There has to be Hill's criteria, has to be fulfilled. So Hill's criteria of causality. Alright? So it was given by Bradford Hill. There are certain criteria which can establish causality. All criteria should be present. So how have we learnt it? What is the best criteria to establish causality, or the most important criteria, guys, which we have already studied? Most important Hill's criteria is temporality. First question yourself. Most important Hills criteria, temporality. Cause precedes effect. It can be done by a cohort study. Then ask yourself, which is the least important criteria? Okay, the least important criteria or the most difficult to establish. Okay, most difficult to establish. This is what? Specificity. Smoking only leads to lung cancer. No, it can lead to so many things. So that's the least important. Then we are going to go in an alphabetical order. Okay, we'll just write the names once, like biological plausibility. Whatever I say, if I say smoking leads to lung cancer, it should have a biological support because smoking will cause inflammation of the lung parenchymal tissues. Okay, so biological plausibility. Then cessation of exposure. If you stop smoking, chance of lung cancer decreases. Coherence of association. Coherence of association means researchers support each other's finding. Then consistency. Consistency of association means findings are replicable. Then seventh, dose response relationship. If you increase the dose, the outcome also increases. Okay, and you also have specificity that we have already discussed. Okay, so dose response relationship, and of course strength of association. Yes, strength of association is given by which study design? So strength of association, guys, it's given by odds ratio in case control. Okay, and of course there is relative risk in cohort. Then there are two more which are taken into consideration: analogy and experiment. Okay, we can do an experiment to establish causality. So the most important is temporality, which is done by a cohort study design. Okay, so this wasn't just about epidemiology, all the golden points, all the study designs, all the errors we have discussed. Let's quickly have a look at some MCQs. See, best study of first choice for assessment of unknown or new disease with no hypothesis. That means nothing is known now. What would you want to do? Of course, we would first want to describe the disease. So, descriptive. Alright. Okay. Cohort, remember, is only done, okay, when there is evidence of association. When there is evidence of an association. Alright. There is some evidence of an association between exposure and outcome. Okay. When we have this evidence, then only we will do a cohort. Because after descriptive, we tend to prefer to do a case control, not a cohort. Okay. See. British investigators conducted a study to compare MMR vaccine history among 1 to 9-4 children with disorder and this much children without disorder. So again, now what are you doing? So you are going retrospectively, guys. Yes. And plus, what is to be done? You already have two groups, children with autism, right, and no autism. And what are you doing? You are just going backwards and asking whether the child took MMR, no MMR. Similarly, here we are assessing the child took MMR, no MMR. So what are we doing? We are going back and looking at the history. So this is a case control. Don't think vaccine is mentioned, so it is an intervention. No. We are starting with two groups. We are going back and looking at the history of a vaccine. The Iowa Women's Health Study, in which researchers enrolled so many women in 1986 and collected exposure and lifestyle information to assess relationship between these factors and subsequent occurrence of cancer. That means we have started in 1986. We have taken information on lifestyle. So let's say smokers. How many women were smokers? Non-smokers. And then we are studying the subsequent occurrence. That means we are going forward. So which one will you prefer? A cohort? Yes? Okay. If a researcher wants to study precedence relationship between exposure and outcome, precedence means cause precedes effect. Okay. Cause precedes effect. Alright. So what study you will do? This year we are asking about temporality. So which study design is best for temporality? Cohort. Okay. Alright. Then in a cohort study, out of those exposed to risk factors, 10 are diseased, and out of those non-exposed, only 5 are diseased. What is relative risk? Don't panic. It is the incidence among exposed divided by the incidence among what? Non-exposed. So we can very clearly see that those exposed to risk factors, 10 are diseased, and those non-exposed to risk factor, 5 are diseased. So 2. That means it is a risk factor. The health authorities are launching a smoking cessation program by designing different activities. They are very expensive, but still see a large proportion of lung cancer will be eliminated if smoking is stopped. So what is this? Obviously a population attributable risk. A study found relative risk of alcohol addiction to have depression to be 2.03. So relative risk is 2.03. That means this is more than 1. So of course positive association. If you are an alcohol addict, you are 2.3 times at risk of depression. Okay. A study found odds ratio of maternal hypertension to have IUGR fetus to be 1:5. What is interpretation drawn? Now guys, look at this. This is odds ratio 1:5 means 1 by 5. Don't write it as positive association. 1 by 5 means 0.2. It's 1:5. So here odds ratio is less than 1. So this is an inverse association. Okay. Alright. Now, here you have to calculate risk ratio. You can do it. Just remember this is ABCD. You've been given everything. Okay. So, you know the smokers altogether is 400. Non-smokers is 600. And when you're asked risk ratio, relative risk. So, what is the incidence among smokers, guys? Total smokers are 400, out of them 120 are smoking, right? And non-smokers are 600, out of them 30 are smoking. So if you do it, you'll get it as 6. So don't just worry, just look at the question. Again, while launching a new health program and policy, population attributable risk is calculated, which best defines it. Incidence of disease among exposed is so many times higher as compared to that non-exposed. This is relative risk. So much disease is attributed to exposure. This is attributable risk. If the risk factor is modified or eliminated, there will be so much annual reduction in annual incidence of disease in the whole population. That is my PAR. Okay. Random and randomization means equal and known chance. Eliminating selection bias and both known and unknown confounders. Intention to treat, discussed, randomized, control trial. Dropouts are not excluded. The major purpose of random assignment in a clinical trial while doing it to eliminate selection bias by ensuring comparability. So see, ensuring that study groups are comparable. Blinding removes bias. Which of the following is true regarding confounding factor? Except, okay. It is associated with exposure. Yes. It is distributed equally. No. It is distributed unequally. Okay. But after the techniques, they get distributed equally. Which of the statement about clinical trials is true? Post-marketing surveillance in phase 3? Absolutely no. 4. Safety and non-toxicity profile? Phase 2, 1. RCT is done in phase 3? Yes. Unit of study in phase 1 is patients? No. It is healthy human volunteers. Okay, healthy human volunteers. Recall bias is mostly associated with case control study. Double blinding means both subject and investigator. So that means both observer and observed group is blind. Best study designed to establish causality, guys. So over here you just have to look at evidence-based pyramid. Cross-sectional, ecological, longitudinal, case control, non-concurrent cohort means retrospective cohort. So of course this is the best study designed to, if you look at that EBM, this is the best study design. Thank you so much. So this was a short quick revision of EPID. I hope it helps all of you. Okay, we've looked at epidemiology in a compiled manner. Thank you so much.